One, and we are live. So we are beginning a brand new division chapter, but it's all the same exact steps. So our previous chapter was dividing by 1-digit divisors. Now we're going to start on 2-digit divisors, but before we're alarmed, remember that we're going to be using the same steps. It'll be just it's just one more step above in terms of complexity, but I think we got this. As long as we know our basic facts, we're going to be in the clear. And for those who guessed it this morning, who am I dressed as? First Halloween costume of my Bitmoji. As Sally. She is my absolute favorite from Tim Burton, and I actually dressed like her last year, if anybody remembers seeing me around.
Nightmare Before Christmas.
It's from, yes, Tim Burton is the artist. Tim Burton is the artist, and yes, Zero is
My aunt loves Sally. My aunt loves Sally.
I love Sally. Last year I went dressed as her. If you remind me later, I'll show you a picture.
Okay, it's later. Okay, it's later.
Later. Okay, guys, we're going to get started on our math.
It's later now.
Our essential question for this chapter is, what is the standard procedure for dividing with 2-digit divisors? So that is what we're going to begin with. And let's review some terms from the last chapter just to make sure that while I'm explaining, we understand the terminology I'm using. So remember, the dividend is always the number that is being divided, not necessarily the bigger number, but the number that is being split. It goes in our table to be shared, right? Our divisor is the number that divides into another. That is our number that tells us what times table we're going to be working with. The quotient is the result or the answer in a division problem, and the remainder is the amount left over after division. And last week we worked in interpreting the remainder and deciding in real life when we would use it. All right, and in case we are still unfamiliar with the setup, it's dividend divided by divisor equals quotient. When it's in our table, our dividend always gets to go inside the house. All right. So, as we started our last chapter, you probably guessed we're going to be starting this chapter the same way. We're going to be dividing with our multiples of 10. Now, who remembers the trick for dividing with multiples of 10? Anybody remember before we begin?
0.
You're looking at the zeros.
Identity, probably.
Not identity. I think we're thinking back on our multiplication with zeros. Does anybody I'm looking out for a hand. Anybody think they remember what dividing with multiples of 10 is going to look like? Nobody. Oh, I see, sorry, I saw Jaden. Jaden, what's up?
But you just have to divide the 6 by the 10, and then that would be the number that would be 6, and then you have to add the zeros.
Okay. Well, you're giving us a specific out there, but yeah, you always look at your basic facts first, right, guys? Box your basic facts, right? And then we focus on zeros. So let's take a look. Thank you to Willow for donating a Bitmoji. Willow has her own catering business serving delicious and healthy vegetarian dishes to local schools. Willow's Farm to Table company just received a request to cater a teaching conference in Berkeley. Woo woo, go Willow. She can pack 20 soups, salads, and sandwiches in a box. How many boxes will she need if 60 soups and salads are ordered? What about 600? What about 6,000? So 5th graders, aside from the obvious that we're working in a chapter that's literally called dividing with 2-digit divisors, what in this problem tells us that we need to actually divide? What clues? I'm looking out for a hand. Oh, I just saw one. Kai, what clues tell us?
They give you the answer.
Right, they give us the total. What is the total that she's packing? 60. Right, usually when we're multiplying, we're trying to find a total amount. They told us, hey, they ordered These hungry teachers ordered 60 soups and salads from Willow's company. So they gave us the total, and then what else is telling us we need to divide? Any other clues in there? Any other clues?
It's the chapter that we're doing.
Hey, I said aside from the obvious, Valentino.
You told us. Because you told
I knew
us
it
it was a division problem.
anyways. I knew it. All right. Nobody else sees any other clues? Come on, we just.
They said, Miss Les, they
Yeah.
said 20 soup, salads, and sandwiches in a box.
Right. It's in a box, and seeing as we're packing things in a box, we're putting them into groups, right? We're putting them into groups. So on your whiteboards, how would you solve this? You don't have to solve it just yet. I just want to see your process. Hold up those whiteboards. How would we solve? Let's just focus on let's not focus on those greater amounts. Let's focus on just the 60 soups and salads. We don't want Willow feeling overwhelmed with all that cooking she's got to do. All right, I see a bunch of people already. Lucy's got it.
Yoshi's got it.
Kayla's got it. Oh, am I missing Yoshi out there? Ashley's got it. Sinjin's got it. Nice job with the boxes too, Ashley. Perfect setup. Good, Kai's got it. Clarissa. I think Seraphine's got it. It's kind of hard on the screen, huh, to see it. Not everybody put their whiteboard up. Come on, guys. I want to see your process.
I just put my whiteboard up.
Oh, Izzy's got it up. Okay, good. Matthias, Julian. Yes, good job, guys.
Yoshi.
So we are dividing 60 by 20. So we're going to have 60 divided by 20. And then we'll focus on these larger amounts. Like I said, we don't want Willow getting too overwhelmed with all these orders. All right. Let's review our steps for dividing with multiples of 10. The very first step is to solve your basic facts. So 60 divided by 20. What should I be boxing? Remember, box your basic facts.
The 6 and the 2.
Good, 6 and the 2. So let's not worry about those zeros just yet. Let's just divide that. 6 divided by 2. How many times can 2 go into 6?
3.
3.
And that's
3
the
times.
answer.
Yeah, you guys are ahead of the game. That's right. I want
And
to
the 2
just
zeros cancel
guys.
2 zeros
Yes,
cancel each other out.
you remembered because I gave it as a preview in the last chapter. You
Yeah,
got a good
yeah.
memory. So our next step is, for those that didn't quite remember, because I know we quickly looked at it last chapter, is to cross out the zeros that are as many zeros that are in the dividend as there are in the divisor, because in the end, which is a step that's a little bit different from our multiplication, we're only putting the additional zeros, meaning we're going to make sure there are no extra zeros. So if there's a 0 in our dividend and a 0 in our divisor, they cancel each other out. So we're going to cross them both out, which means we have no zeros to carry over into our quotient. So 60 divided by 20 is 3.
3.
How could you check this to make sure?
You multiply.
Multiply. What would you multiply?
3 times 20.
3 times 20 is 3 times 20, 60?
Yeah.
Then we are in the clear, good to go. All right, let's try. Now we're going to get a few more soups and sandwiches. What if we had 600 soups and sandwiches and we're splitting it into boxes of 20? Again, first step, box your basic facts. What's our basic facts? Yet again, same one.
Answer 30. Answer 30.
6 and what?
0.
2. 6 divided by 2, which is?
3.
Yay! All right, our next step. Cross out as many zeros in the dividend as there are in the divisor. So
The answer is 30.
we have 1 0 in our dividend, 1 in our divisor that cancel out. We have 1 0 left over. Is there another 0 in our divisor to cancel out with that 0?
No.
No. So what do we have to do with this last additional 0 left over? Annex it to the quotient. Does anybody remember what it means to annex? Why I don't say the word add and I say annex instead?
Because
I'm gonna look out.
not adding.
Right. If I added 0 to 3, 0 plus 3 equals 3. Am I adding 0 to 3? No, I'm putting the 0 next to the 3, making it a 30. So to annex the 0 is actually changing the place value of that 3. If I just said to add the 0, 3 plus 0 would be 3. We're not adding the 0, we're annexing the 0. All right? All right, last one. We've got the biggest amount yet. 6,000 again. Box your basic facts. Our basic facts, again, same one we've been doing over and over and over and over and over.
it's 300. Easy.
6. Oh, okay. 6 divided by 2 is?
3.
And let's start crossing out some zeros.
Annex 2
We got there's 1 0 in our dividend, 1 in our divisor. Do we have any other zeros to cancel out?
No.
No.
Don't see
So how many zeros are left?
2.
2. What do we do with those 2 zeros?
So it's
Add them, annex them. So our final quotient is
300.
300. All right.
That was really easy.
And that means Willow's going to need 3 boxes for her 60 orders of soup. She's going to need 30 boxes for her 600 orders of soup and 300 boxes for her 6,000 orders of soup. Must be some very popular soup and salads there. I think Willow's going to have to cook for us now. What do you think, Willow?
Willow, cook soup for me.
All right, I'm just going to pause my recording really quickly, and we're back. All right, so not that bad, pretty easy. I have a quick question for you. I know that remembering a step, saying something like, you have to cross out the zeros because Ms. Velez said so, but do you actually get why you're crossing out the zeros? Because there's a lot of things we do in math that you're just like, I'm just going to remember it's the step. But I'm more interested in knowing, do you actually get why we're doing that step aside from me just telling you to do it?
I do.
Why? Who said that? I'm sorry, I'm looking out.
Chris.
All right, Chris, why are
Celeste?
yes.
Where's Miss?
Go ahead, explain to us. Why would the case be that we're going to be crossing out zeros besides me telling you cross out the zeros?
Because if we didn't cross out the zeros and put them in and extend with our quotient, we would get a bigger quotient than any of the bigger quotient than the divider, than the divisor, and
right.
Then the divisor and
Well, I'm going to show you a little something. Every division problem is a fraction. Hopefully that glare. I'm going to turn the light off for just a second so you can see it. Every division problem is a fraction. Good way to remember. Isn't that a division problem? Do you see it?
it's a fraction.
It's a division sign. Okay, every division, right, why? Because a fraction is a part of something, yes? So when you are dividing, you are finding a part of something. You are given a whole, like 5, and I'm splitting that whole 5 out of 1, okay? Yes? So when I have a division problem, I'm actually looking at a fraction. And if you remember what we did with fractions, or what you guys did with fractions last year, you've probably worked a lot with finding equivalent fractions. Yes? This is sounding familiar?
No.
No, I'm gonna tell Miss Hope.
Yeah.
So if we have 500, this line in a fraction means out of 100. Does everybody see that? 500 out of 100. I'm also saying 500 divided by 100. So fractions and division are the same thing.
It's 5.
Exactly, it's 5. When we look at equivalent fractions, we are dividing our numerator and denominator by the same amount. So 500 over 100, let's say we divide it by 10, would be 50
And 10.
over 10. If we divide by another 10,
It'll be 5 and 1. So, yeah.
it would be 5 over 1. And if you know anything about fractions that have a whole number over 1, 5 over 1 is the same as 5. So 500 divided by 100, when I solved that, all I did was cancel, 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 cancel. I'm left with 5 over 1, which would be a whole number 5.
Yeah, but if you kept the zeros in, you would get 500,000 instead of 5.
Where do you see 500,000?
No, so 50,000, my bad.
Over what? Where are you getting these bigger numbers? We're not multiplying. Only when you multiply can you get a bigger number. So you wouldn't have 500,000, you would have 500 over 100.
I know, that's what I'm saying.
And and when you divide, your numbers are getting smaller because you're putting them into smaller groups. So your numbers are never going to get bigger. So it went from 500 over 100, divide by 10 is 50 over 1. Divide by 10 is 5 over 1, and then we can't simplify any further. There's no other numbers we can divide by that would give us anything smaller than those. So we get 5 over 1. So when you think of a division problem, you're thinking about making your dividend and your divisor smaller and smaller and smaller until you have the smallest amount of groups that it can be split into. So in this case, when we're crossing out zeros, we're not just crossing out zeros. What we're doing is, instead of saying 500 divided by 100, we're saying 500 divided by 10 and 100 divided by 10. Cross out a 0. Now it's 50 out of 10. Then we're taking 50 out of 10 and saying 50 divided by 10, 10 divided by 10, and we get 5 over 1. So when we're crossing out zeros, we're not really crossing out zeros. We're just saying, I'm going to break this into even smaller division problems. And when I'm crossing out those zeros, it actually means I'm dividing by 10 and by 10. Instead of taking the whole 500 and dividing it by the whole 100, I'm dividing it by 10, cross out a 0. 500 divided by 10 would be 50. Then I have the 100 divided by 10, cross out a 0. Gives us 10. Oh, I can make it even smaller. Let's cross out another 0 and 0. But the fact that the reason why I wrote it as fractions is that you could see you're not just crossing out zeros, you are dividing by 10. So here, if I wanted to divide again, I couldn't, because these two numbers, my dividend and my divisor, are directly correlated with one another. They are connected. So I cannot just cross out a 0 and 1 if there's no 0 in the other, because I'm not just crossing out zeros. I'm dividing by 10. So if one of the numbers, let's say I had, for example, a 50 over here and a 1 here, I can't just cross out this 0, because whatever I'm doing to my dividend, I have to do to my divisor. I can't say 50 divided by 10 here if 1 has no 0, what has nothing, no 10 that can go into it. So I'm going to have to keep this as a 50. Does everybody see? I know sometimes fractions gets a little confusing, but does everyone see we're not actually just crossing zeros out? We're actually dividing by 10, dividing by 100, right? You guys see that? It's a little tricky with the fractions, but I was hoping to visually show you that when you're crossing out a 0, you're not really crossing out a 0. You're dividing your dividend and your divisor by 10, making it exponentially smaller until you have just that 5 left over and you can't divide anymore. You can't cross out any more zeros. How are we feeling with this? I know it's a little confusing with the fractions, but does everybody get why you cross out zeros? That you're not really just crossing out zeros, you're dividing your dividend divisor by 10, by 10, by 10. You're doing repeated little mini division problems. Divide by 10, divide by 10, divide by 10, divide by 10. That's what those zeros are that are crossing out. You're not crossing the zeros out. You're dividing your dividend and your divisor by 10. That's why we cross them out. Okay?
Excuse me, Miss
Yes.
Wallace? Dominic.
Yes, what's up?
So can you actually like divide? So can you at least like divide 5 like and get a negative number? Would that work? And have a connection?
So with division, we seem to. This is like we've gotten this kind of question a few times. You're not going to get negatives in division unless you are working with negative numbers. There's a difference between a negative and a decimal. You can get a decimal as an answer, and a decimal just means you have a number that is less than 1.
It's less than 1, but it's greater than 0.
Exactly, but greater than 0. A negative means it's less than 0. So like if you got 0.00345, guess what? That's still more than 0, right? But so you're not going to get a negative unless you're working with negative numbers. You guys are mixing up decimals and negative numbers, right? Decimals decimal's another word for a fraction. So if I took something like a 1 and I divided it by 2, you would get 0.5, which is the same as saying half, which makes sense. If I have one thing and I split it with 2 people, I'm going to get a half and a half. Now that's not less than 0, is it? It's just less than 1. All right? So you're not, so when we're dividing, you're not, unless you're working with negative numbers, you're never going to get a negative. You can get a decimal, you could get a fraction, but you're never going to get a negative. All right? Good question. All right, guys, so let's try a few more of these using that trick. Just wanted to make sure, maybe I'll put it as a bonus question, that you understand that we're not just getting happy with our crossing out. We're not just crossing numbers out here and there. We are actually doing mini division problems all along. So let's try out 560 divided by 70. And for reference, guys, we're on page 120. You with me? Yeah? All right. First step, as always, box your basic facts. Box your basic facts. What are our basic facts here?
506 divided by 7.
Try that again.
56 divided by 7.
56. There we go. 56 divided by 7. Don't worry about the zeros yet. Let's just solve that. 56 is in the 7 times table. Hopefully we are strong with our 7 times table. How many times can 56 be divided by 7? How many? 7 times what? 8. All right, I'm going to keep my basic fact inside my box because sometimes I get a basic fact that has a 0 in it, and I want to make sure that the work I'm doing with my zeros, annexing my zeros, is not interfered. All right, Now our next step, which we just finished talking about, is to see if we need to cancel out any zeros. And what we're doing when we're canceling out those zeros is we see, is there a zero in both our dividend and divisor? Yes, right? So what we're really doing is we're saying 560 we're going to do divided by 10 is going to be 56. Whatever I do to my dividend, I have to do to my divisor. 70 divided by 10 means we cross out that zero is 7. So instead of dealing with 560 divided by 70, I'm just dealing with 56 divided by 7. Does everybody see why I canceled out those zeros? I did a little mini mental math and divided within my problem. So since there's no zeros left over, they've both got canceled out. 8 is my final answer. All right? Are you with me? Silent out there.
Yes.
All right. All right. Let's try another one.
Nah, you lost me a century ago.
A century ago? I wasn't even here for a
Yeah.
century. What part are we confused with? The zero crossing out?
It was
6,000.
a joke. It isn't real. It's just a
Oh,
joke.
all right. Want to make sure you're with me. All right, first step.
Yeah.
Box your basic facts. Box your basic facts. What are my basic facts here?
63 divided by 9.
63. I'm going to take that little punctuation mark out. And 63 divided by 9. Don't worry about the other zeros right now. Let's solve. How many times does 9 go into 63?
7.
7.
7.
Good. All right, now here's the fun part, the canceling out. I'm going to see if I can divide both of these by 10. Can I?
Yes.
Every time you divide, you cross out a zero. So I have a 0 here and a 0 here, which means those two can cross out. Do I have 0 in both of these to divide by another
Nope.
10?
No.
No, so I'm going to have to annex this 0. And my final answer will be
70.
700.
Whoa, come on guys. 700.
700.
70. Ah,
50 million?
you're scaring me, guys. You're scaring me.
70 million?
Nick, it's not that far.
All right, let's try another one before I cry over here. All right, 240. Ooh, I like this one. 240 divided by 10. Who would like to tell me what the basic fact is here before anyone's saying, I don't see how they go into each other.
24 divided by 1.
24. Someone said it. I think it was Danielle. 24.
Divided by 1.
Yes.
24
Pretty is that?
24. So.
What property?
Identity?
Identity property.
Identity.
Let's solve our basic facts. 24 divided by 1 is 24. Let's see if we can get rid of some of these zeros, shall we? Are there
We got rid
zeros
of
in
all
both our dividend and our divisor?
Yes.
Yeah, so they can both be divided by 10. Divide by 10, divide by 10. Does everybody see that? 240 divided by 10 is 24. 10 divided by 10 is 1, right?
Yes.
Seeing where the zeros are disappearing. Okay, so no zeros left to annex. Our final answer is 24.
24.
Nice. Very nice. All right. What do we got left? These are so... Ooh, I want to do one with a lot of zeros just to make sure that we're not making any zero mistakes. Oh, yeah, good amount.
The more zeros, the better.
A trillion.
Divided by...
A trillion.
Google.
Oh, I can't sit here and... I did that once where I wrote all those zeros for you guys. You remember that? In the
What about
first
the-
chapter? The
Oh,
very
yeah,
first
I
chapter. Yeah. All right. I'm
Thank
not doing that again. That took forever. All right.
But then where's the answer?
Box, guys. Thank you. Box your basic facts. So what are my basic facts here?
2 and 2.
2 divided by 2.
2.
Let's just focus on that. That's where the bulk of our work goes.
That
2 divided by
equals
2
1.
is 1. All right, let's see if we can cancel any zeros out. I start with my divisor. I have 1 0 here, so I could divide by 10. 1 0 here, I could divide by 10. Anything left in my divisor? No, so we can't divide by 10 anymore because whatever we do to our dividend, we have to do to our divisor, right? Think of your fraction. It has to be an equivalent equation. So instead of saying 2,000 divided by 20, the same exact thing, 200 divided by 2 is going to give me the same answer. We have how many zeros left?
2.
1, 2, 1, 2. Does everybody agree that 2,000 divided by 20 is the same as 200 divided by 2? Are those equivalent problems?
Yes.
Yes. Why are they equivalent? Because they're going to give me the same exact quotient. 2,000 divided by 20 is 100. 200 divided by 2 is 100. So when I canceled out the zeros, all I was doing was simplifying my division problem and making an equivalent problem that was easier to solve. All set, all good? Yeah?
Yeah.
All right, let's see if you can do it in your head now.
Easy.
Cancel out the zeros in your head. Ready? In your head, so no writing. No writing.
Okay, easy.
Whiteboard away.
Okay.
Easy.
45,000 divided by 90. Go.
45,000 divided by 90.
45,000 divided by 90.
No, not
I think some people are writing.
500.
All right, you know what? So that we make sure, no one is just copying. You can use your whiteboard. No, but you can only put your answer on it. Ready?
Yay.
I will look for the first people to have their whiteboards up. All right, yes, it was 500. Let's try another one.
Oops.
Let's try another one.
5,000.
Ooh, this one's got a lot of zeros in it. You're gonna have to mentally cross out zeros. Ready? 30,000 divided by 50. 30,000 divided by 50.
Oh, I know.
6,000.
Put it up, put it up. On your board. Divided by 50. 30,000 divided by 50.
6,000.
5,000.
Oh, I'm looking for. Oh, nobody got it.
What?
Answer.
Ready? 30,000. 30,000. I know why too. It was a basic fact mistake. 30,000. Watch. Divided by 50. It was a complete basic fact mistake. Your basic fact is 30, not 3. 30 divided by 5 is 6. Cancel, cancel.
600.
1, 2. I saw only 6,000 on the board.
Oh, God.
I want to do your work. But
That's not true.
who? You didn't have that before, Sinjin. You had a 6,000.
36, and then I was like, wait, no, that's
60
the
million.
problem. And then I tried to erase the 6, but then
Well, I
erased the
think
3.
fifth graders. I think.
Yeah, you think?
Shh. I think I just proved my point for why you need to write down all your work. Just saying.
You
Oh.
were rushing us. You're
Yeah, you were
rushing us.
rushing us.
on the first one. So. You're rushing
Oh,
Yeah, you were
Gee,
rushing us.
You said
You're
you're
the
the
one
one
who
who
told
said
us to be
I
responsible.
the first
I-
people.
That was my little science experiment.
Christopher,
Always-
people are using
Oh,
headphones.
5th graders, always write
Miss
down your
Celeste?
work, because all of the
Miss
mistakes that I am seeing are not because the questions are complicated. All the
Because you were
mistakes I'm
rushing.
seeing
Miss
is
Celeste.
because you are rushing and
No, you
not
are
writing
rushing.
out your work.
You
I'm
were rushing us.
Shh,
Celeste.
shh, 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 shh,
Miss
shh.
Celeste.
Okay, I don't know about you, but I'd love to let you go on your break. Just give me 1 second.
Proves nothing.
It does. It proves
doesn't.
that
You rush us.
That
Fifth
when
grade.
you're rushing us.
I'm gonna
we are on
wait.
something straight.
all this proves is that even the best of us sometimes rush through our work or don't show all our steps. And the errors that I do see are usually only off by 1 digit. All the mistakes I see have all of the proper math done, and then the digit is literally off by 1 number, like an extra 0 or not enough zeros. So all I was trying to do was show you that there is a benefit to taking an extra second to write down your work. But it was definitely a challenge, and I was definitely rushing you. I can 100% agree with that. It was just for a fun, friendly little competition. So we'll try another one in the next class, 5th graders. I just want to make sure, 5th graders, thank you. I just want to make sure that aside from the little competition, is everybody confident with doing the steps for this?
Yeah.
Yes? And does
every?
everybody understand why we're canceling out zeros? We're not just crossing out of nowhere.
Yeah.
Okay, so I think this will be pretty easy for you. I would really love for you to the questions I gave you today are actually from the reteaching page in your workbook, so you can work in there first before you answer on the forms, right? I hope you realize that on the Google Forms, I'm always taking the questions either from your practice or your reteaching page, so you can work in those books first, do your equations, and then just transfer your answer onto the Google form. All right, so do your work and then get it on there and make sure that you have the right amount of zeros and that you're boxing the correct basic facts. All right, good to go, guys?
Yes.
What page?
Yes.
What page?
Well, I put them,
Yes.
it's the R page 5-1, but I put them on the Google form, so you'll see the same questions pop up, okay?
Okay, so wait. Do we have to write it in notebook, right? Do we have to write it in the book? I mean,
Unless
not the notebook,
if you have
workbook.
space in the workbook, you can write it in the workbook. I always just think that they don't give you enough space, so I usually say to do it in a notebook.
Yeah, because the last year they didn't
Yeah.
really let us do that because they were just using
Well,
it
for something like this where you're literally just boxing the basic facts and you're not doing like all the division steps, I think it'd be okay to do it in the workbook for something like this. All right?
Okay, so
All right, bye. I'll stick around for some questions, okay? I want to let other people
Bye.
dismiss.
Bye.